Hello, everybody. Today we are gonna be doing homework questions for lecture one, and I'm gonna do like short videos so you guys can skip through it. If you know the question, just go to the next video. Right? So I'm gonna just dive right into it. So the part A for this question is checking if this equation satisfies this. It's not necessarily satisfies that they're looking for the values of r, and then we're going to check if this equation satisfies this with the values of r subbed in. And so the first thing we'll do here, mind the quality because this is a screenshot, that's why it looks so horrible. But all right, so we have, what do we have here? We have 2y prime plus y prime minus y. This is double prime. I don't know why I said prime for both. And then I have the equation y equals e or x, and I'm looking for r. So, well, I'm gonna need a couple things. I'm gonna need the first order and second order here. So, the first order would be r, e, r, x. I'm not gonna go through how to derive, because you guys should have plenty of practice for that from last term and from this term as well. And so this is gonna be r squared e r x. Okay, so since that we got these two, now we can sub them in. So we got, well, what do we got here? 2 r squared e, oops, e r x, and then plus r e r x minus e to the r x equals 0. All right, so now when you look at this, you're like, what can I do with this? You can't just leave it like this. You can't pull out an r because this side is missing an r. But you have e to the rx common in all of them. And so, as you can see, like right here, this term I can pull out. This is the same term, and that is also the same term. I can pull all these out. I can do e to the rx right here, right? And I'll choose it back to black. We'll be left with 2r squared minus r minus 1 equals 0. Don't forget your minus 1 here. A lot of people do. It doesn't go away. It's still a 1. When you take it out, you're basically dividing by the same term. It gives you 1. All right, now what you got to do is you got to simplify this. It's a quadratic equation. So one way you can simplify this is you can multiply 2. You can multiply 2 times negative 1. Actually, I'm going to choose a different color so it's easy to see. So we're going to take this and then take this 2. We're going to do 2 times negative 1, which gives us negative 2. And you're going to go, what two things multiply to negative 2, which is obviously negative 1 and 2. And but it has to be also, what are the terms that would multiply to negative 2 and add up to your negative 1 here? And so it's actually the same, which is funny. But so yeah, so negative 2 times 2, that'd be negative 2. And then negative 1, sorry, negative 1 times 2 is negative 2. And then negative 2 plus 2 equals 1. And that actually doesn't give you the right one because, oh, this is supposed to be a plus. I don't know how I missed that, but okay. As you see, it's right here. I just brought it down. Yeah. Okay, so these are my two terms. So what you would do is, actually, I'm just going to factor the whole thing here and then I'll write it in. So now because I have 2r squared stays the same, you get your negative 1, which will be negative 1. You sub it into the first term, so it would be r. And then you get your 2 plus 2r. You keep it. And then you do your last term, which is your minus 1. All you do is you replace this middle term with this r and then 2r. Okay, and you plug them in the middle, right here. Okay, so now that you got this, you can factor by grouping. So what I could do here is I could group this one and this one, and I can also group this one and this one together. So to rewrite this, we'll get 2r squared. I don't know why I'm teaching factoring, even though you're supposed to know this, but I know some people do be rusty. I mean, I'm rusty when it comes to factoring, so that's why I'm doing it. Now what I could do here is I could pull out some stuff. So 2r and 2r I can pull out, and I can pull out a negative here, I think. So let's test this out and see how it works. So I'm gonna pull out a 2r, and that was gonna leave me with an r plus 1. And here, I'm going to plot a negative. And now we'll leave you with an r plus 1. All right. Technically, I pulled out a -1. So there's a tiny 1 here. All right. And so here, you can group these two together. And so I'll do it in red. So now I have 2r minus 1. So I grouped these together. Right. And I'm going to also group all my r plus 1. And that's factored form. And so what I'm going to do is I'm going to bring this and sub it in here. Whoop. There you go. And let's sub that back in. So we'll get e r x, and then we'll also get my 2r minus 1, and I'll get my r plus 1 equals 0. Now what you want to do, what it's asking for is values of r. So this, we covered this last lecture. This goes to infinity because it's an exponent. And so these ones here, what you would do is you do 2r minus 1 equals 0. Isolate for r. So take this to the other side. You get 2r equals 1. And then you divide by 2, which you'll get r equals 1 over 2. And for this one, you'll have r plus 1 equals 0. And now you get r equals -1. All right. So what are your solutions for this equation? What you could say is you could say, here, I'll write to the side. Actually, no, I'll write under so it's together. Solutions, all right, for 2y double prime plus y prime minus y equals 0 are, we have e to the x over 2, because we subbed into the main equation, which is this one. We subbed it into there, right? So that's one equation, and the second equation is the negative, so it'd be e to the negative x. These are my two equations that are solutions to, these are my two functions, are solutions to this equation, differential equation. And so the part B says if R1 and R2 are the values of R that you found in part A, okay, which we did, R1 and R2, this is R1, here R1, and we'll make this R2, all right? And to show that every member of the family of function, this is also a solution. What does this mean? This is math terms, and actually this is pretty easy to decipher. And we'll go here to the side, and we'll decipher it here. So what it says is y equals a e r1 x plus b e r2 x. And so what we're going to do, we're going to sub our equations in. All right, so we have a is a constant. This is what they're giving us. We don't know what a is, and we don't need to know what a is for now. B, well, we have a negative x plus b, and our r2 is our x over 2. You guys are wondering where I got these from. R1, R2. All right, and here it says is also a solution. So it's saying check if this is also a solution of this quadratic differential equation. And so since now that we have it subbed in, what we can do is get our derivatives. Since if you look up here, we need a second order and we need a first order as well as the original order. And so this is our original order. And here we can have our first order. And so how do you get the first order? Is you derive. Since this is a plus, you can derive this separately. So you can derive this separately, and you can derive this separately, and just add them together. And so the derivative of this would be a negative a e to the negative x. And the derivative of this would be plus, so plus stays, 1 over 2 b e x over 2. Right? Now my second order is I'm going to have to rederive this. So the negative comes down, cancels out with this negative. This becomes a positive, and it goes back to the original. Right? Plus, this still comes down and multiplies by 1 over 2. So this will have 1 over 2 times 1 over 2, which is 1 over 4 b e x over 2. Now we go to our equation, which is 2y the second order, and then y first order minus y equals 0. All right, and now we sub the shit in, and so what do we get? 2 stays, right? The 2. Now we put these in brackets because this has to distribute in, and we have a e negative x plus 1 over 4 bEx over 2, right? That's our first term, plus our second, which is a negative a, e to the negative x, plus 1 over 2 bEx over 2. And then we have a minus our second term. I don't know what the hell was that bracket, which is a, right, plus b. Well, this equals to 0. Now let's just distribute stuff in. So this gets distributed in here. This negative gets distributed in here. So let's get that done real quick. It's 2a to negative x plus 2 over 4, which is 1 over 2, right? This becomes 1 over 2 when you do 2 over 4. We'll do it in 2 steps. There you go. Just so you guys don't see me pulling out numbers out of my ass. And this negative, this just becomes negative. Nothing happens to this term, really. All right. And then this negative distributes in, so you'll get minus a to the negative x, minus b x over 2, and all this equals to 0. And so what can you do here? Let's get us a red marker. These terms, so you see this is a negative term, this term, and we have this term, and this term is all the same. And so when you look at these, you have a negative and a negative, so that's negative 2, and you have a positive 2 here. So this with this and this cancels out. Now what you'll have left is these other terms. This turns actually, oh, let me make a better error here. This turns into 1 over 2, right? I want to do in other steps. And so what we have here is we'll have this term, which is 1 over 2, bex over 2. And we have 1 over 2, bex over 2. And we have a negative 1 bex over 2. So when you add these two together, you see here, this one and this one will give you 1 bex over 2. And this one will give you minus bex over 2. And you see these ones also cancel out, right? And so this whole thing is actually equal to 0. And so the answer is yes. Yes to this question. And says if this and this and this, show that every member of the family function is also a solution. And we just showed that every member is a solution. And that is our question number 1.